Welcome to the AP Calculus video unit preview for Unit 2, Derivatives. You may want to follow along with the unit plan. This is a very long unit consisting of 15 lessons coming from chapters 3 and 4 from the textbook. The focus of this unit is derivatives. The transfer goal comes from the course description posted on the College Board website. Take a moment to read the course description. If you're following the dates outlined in my planning calendar, this unit will begin on the 30th of August. Notation. There is a nice summary of the commonly used notation for derivatives on page 101. You may notice that not all forms of the notation for derivatives are listed. Even so, this list is a nice starting place. Scholars must know different derivative notation. I strongly recommend that when you assess scholars, you use multiple forms on homework, exit tickets, whatever. I typically call on scholars to write various forms of notation on the board for a couple of weeks into Unit 2. Vocabulary. Scholars tend to use the word slope inappropriately. If they do this on the AP exam, they will not earn points. It is very important to correct these mistakes every single time they do it, so they learn what specific words mean or the type of information these words provide. For example, if I ask scholars to find the derivative, I expect the answer to have x's in it, unless of course I am deriving a constant. Whereas if I ask for the slope of a line tangent to the curve, I expect the result to be a number. When finding the average rate of change, I will always expect a number unless I provide ordered pairs that contain variables. I would tell scholars these little tricks so that when they read different types of vocabulary or instructions, they know what to do. Lesson snapshots. Let's take a look at the lessons contained in Unit 2. Teachers have been provided 2 annotated model lessons, 2 unit exams, and a performance task. Lesson 1. Derivative of a function. The focus of this lesson is to switch from limit mentality to derivatives. Scholars are still using a difference quotient, and derivative rules are coming shortly. Some teachers may show scholars the power rule at the end of this lesson. It is important that teachers ensure that scholars have familiarized themselves with the definition of the derivative using a limit before making the switch to rules. Scholars will be presented with questions where instructions only say to evaluate and that require them to use the definition of derivative. You can teach them to go through the manipulation or how to pull the function from the difference quotient and then derive. Use a pre-calculus approach to show how intervals of increasing and decreasing along with extreme values helps you graph the derivative. These concepts will be presented in multiple lessons throughout this unit. Example 6 is a great way to segue into the next lesson. Challenge your scholars to recall the example to apply it to the next lesson. Lesson 2, Differentiability. Lesson 2 is provided as a 5-step annotated model lesson plan in Blackboard. I can't stress enough how important it is for scholars to pick out points where a graph is not differentiable. This concept will be assessed often and many times coupled with discontinuity. Scholars have a hard time telling the two concepts apart. After seeing that a function is not differentiable if it's not continuous makes the statement differentiability implies continuity a no-brainer. And one might consider only listing one condition for the intermediate value theorem as the text does here in Theorem 2. Many scholars apparently teachers thought this was acceptable, me included. However, at the AP reading for the last year's exam, I learned otherwise. Scholars who did not list both conditions, continuous and differentiable, for question 6, part D, lost both points available. Scholars will also learn how to use their calculator to find numerical derivatives in this lesson. Rules for differentiation. Lesson 3 is provided as an investigation annotated model lesson plan in Blackboard. In this lesson, scholars will investigate functions and their derivatives to come up with basic derivative rules such as the power rule, quotient rule, and product rule. They will also learn how to apply basic derivative rules using a data table. Higher order derivatives will be taught, and finding horizontal tangents will be revisited using a calculus approach. Lesson 4, Motion along a line. In this lesson, scholars are challenged to apply derivatives to a real-world situation, motion. I begin the lesson by defining various terms and pausing for a few minutes on key terms such as position, velocity, and acceleration. Scholars have a basic and many times non-mathematical knowledge of these terms. To drive these concepts home, I walk around the room at varying rates, throw objects, etc. Showing scholars how straight line motion shows up graphically is important. I don't feel the text does a great job using words such as left and right to describe positive and negative motion. I suggest you create a handout to help define these terms for scholars and solidify the learning using graphs. Lesson 5. Derivatives of trigonometric functions. This is a short lesson and a great place to reinforce concepts such as proper vocabulary and finding tangent lines. My scholars often struggle with recalling how to evaluate trig functions, and I will remind them of their pre-calculus days memorizing the unit circle. Page 5 of the AP Calculus AB course description reminds teachers and scholars that knowledge of the unit circle is expected. Lesson 6. Review for the Unit 1 exam, Part 1. This unit has 2 exams. The first exam covers Lesson 1 through 5, which is basically Chapter 3 of the textbook. Teachers are encouraged to create an exam review for scholars. In my classroom, I will take a day of instruction to review key concepts with scholars and then send them home with additional practice to study on their own. Lesson 7, Unit 1 exam. Teachers should take note that there is a multiple choice and a free response section of the exam. Make sure both sections are given to scholars. Officially, this lesson is the culmination of Quarter 1. The remainder of the unit are included in Quarter 2 and the concepts will be assessed on CA2. Even so, if you are able to teach more lessons in Quarter 1, then do so. It is always better to be ahead of the game when teaching. CA1 material was covered in person at Collaboration Day Kickoff. If you have more questions about the assessment, please reach out to me. Lesson 8, the chain rule. The chain rule is extremely important for scholars to master. The textbook takes 2 approaches to teach the chain rule. In my classroom, I focus only on the outside-inside method. I don't believe the textbook does a good job of presenting chain rule problems, so I include a lot of my own custom examples. I show scholars how to pull data from a table while applying the chain rule. I also show scholars a variety of functions that they will need to apply the chain rule to, including CA2 specific type problems. Keep in mind that all the lessons remaining in Chapter 4 of the textbook rely on using the chain rule. Do not use your time teaching Example 6 from the text. Parametric concepts are not taught or assessed on the AB course. If your campus offers Calculus BC, then do not skip this concept. Lesson 9, Implicit Differentiation. This lesson is not as difficult as it looks. Scholars catch on to the calculus pretty quickly. If you have scholars who find algebraic manipulation challenging, they may need some extra assistance. This is the perfect lesson to build up algebra skills. Begin the lesson by drawing a circle and discussing why a circle is not a function and how it can be a function if defined in pieces. Scholars need to recognize when implicit differentiation is necessary and, of course, how to derive implicitly. I always write the step-by-step procedures on the board in a place where I will not erase them. When showing each problem, I use the step-by-step methods to find the derivative implicitly. A big takeaway from this lesson is how to implicitly derive a function that includes a product rule. I have seen this concept tested numerous times, and I assure you it will be assessed on CA2. Lesson 10, Derivatives of Inverse Trig. Inverse trig derivative rules need to be memorized. Perhaps you or your scholars can come up with some way to make memorization easier. Scholars only need to memorize 3 of the inverse trig functions and then know which cofunction identity goes along with it. Show scholars that they only need to add a negative to the cofunction and the derivative is the same. They may have trouble saying the derivative of pi over 2 is 0, but I'm sure you can help them with that. To add a little more rigor, I would include inverse trig derivative rules that have rational functions inside. This is another algebra intense lesson once the level of difficulty increases. You can be assured that more challenging problems will be on the Unit 1 assessment. Lesson 11, Derivatives of exponential and logarithmic functions. This is a straightforward lesson and the last of the derivative rules found in the textbook. The rules of exponential functions with a base of e, as well as the natural log function, are the most commonly assessed rules for this section. Exponential and log functions with a base other than e are not often found but will be assessed on the unit exam to ensure that scholars have familiarized themselves with these rules. Another unit exam expectation is a problem similar to example 7 from the textbook. Use properties of logarithms to manipulate something that isn't a function into something we can take the derivative of. Lesson 12, Derivatives of the Inverse Function. This lesson is not in the textbook, but has been assessed on past AP exams. Usually, derivatives of inverse functions is assessed in the multiple choice section, but it has been known to show up in the free response section before. If you need material to work with, you can look at the archived materials for calculus on Blackboard to create your own lesson. Make sure you teach scholars how to find the derivative of inverse functions using a data table. This is question 21 on CA3, where scholars are asked to find the derivative of the inverse function using a data table. Make sure that you teach this lesson. Lesson 13, L'Hopital's Rule. This is the last lesson of new material in Unit 2, L'Hopital's Rule. In Unit 1, we promised scholars we would teach an easier way to find limits. Well, here it is. There are several indeterminate forms that can be taught for L'Hopital's rule, but we are only going to teach 2 of those forms in Calculus AB, 0 over 0 and infinity over infinity. The textbook offers material for all of the indeterminate forms. Do not teach past example 5 unless you are teaching the BC course. It is important that you tell scholars to check that L'Hopital's rule applies prior to applying the rule. They may just jump in every time and find themselves confused when the problem doesn't work out. You must have an indeterminate form for L'Hopital's rule to apply. Lesson 14, Review for the Unit 2 exam, Part 2. Again, this unit has 2 exams. The second exam covers lessons 8 through 13, which is including Chapter 4 and Section 9.2 of the textbook, along with a custom lesson for the derivative of the inverse. Teachers are encouraged to create an exam review for scholars. In my classroom, I will take a day of instruction to review key concepts with scholars and then send them home with additional practice to study on their own. Teachers should take note that there is a multiple choice and free response section of the exam. Make sure both sections are given to scholars on exam day. There is an exploration activity included in this unit that was written by Texas Instruments. Using technologies, scholars explore how average and instantaneous rates of change differ. You can use a flex day in class to complete the entire activity, or use part of a class and just complete exercises 1 through 7. I like to send this activity home for scholars to complete. When complete, scholars can write about a relationship between average and instantaneous rate of change. As always, it is my pleasure to be your CTL and collaborate with you. Please feel free to reach out with questions, comments, or concerns. I am here to help.